All right. In this example, we are looking for the line that is parallel to V that goes through the point -2, 0, and 4. And so from equation 1 in the notes, we know that R of T is going to be given by x naught, the vector, plus T times V. I don't know why I put it 1 there. So this is literally just plugging in directly as vectors. And so the x naught is the components of this point here. So we have -2, 0, and 4 plus, and then t is our parameter, and um, our point that we're going through is the components of v. Since that's kind of like our slope, that's what we want to be parallel to. So you can kind of literally think of this as like the y-intercept, right? This would be like b, this is like m would be the vector here, and then this would be like x, the t there. So there is the equation of the line through this point parallel to our vector v. If we wanted to write this uh, component-wise, then x of t without the variable is going to be -2 plus 2t. That's literally reading it off the top part here. Y of t is going to be equal to 0 plus 4t, and then that's a y. And then z of t is going to equal, looks like 4 plus, actually, minus 2t. And that would be then the last equation. Okay, I hope that was helpful, and I'll see you in the next video. In this example, we want the equation of the plane through these 3 points. So just like in the previous one a day, we're going to compute the vectors p1, p2, and then also p2, p3. And this gives us 2, 0, -1. And this gives us -2, 3, 0. We need these to find the normal. So we're looking for the normal right now. Okay. And so if I take and I compute the normal, which is going to equal P1, P2 cross with P2, P3, okay, this cross product yields 3, 2, and 6. Okay, so that's the normal that we need. And then to write the equation of the plane, what we need, now that we have in, is we need to find what P0P is. P0 is just any of the points, P1, P2, or P3. Uh, I think for this one, I'll choose P2, and P is going to be some arbitrary point. So you can think of P as like having components X, Y, and Z. So I'll choose P2 since that's just the one above it. P2, P. So I'm going to take P and minus it from P2, and so that's going to give me then P2, P0, or I guess P really. Nah. That's going to be P2 is going to play the role of P0 here. It's going to give me, it looks like X minus 2 and then X, Y and Z. Okay, so that's that. And now I'm going to dot this vector with my normal that I just found down here, and then simplify to write the equation of the plane in standard form. So we have 3, 2, 6 dotted with X minus 2, Y, and Z. And you'll notice that these are really nice because the components are zeros in the X and Y for P2. Okay, I know that that's equal to 0, and so I get 3x minus 6. If I add the 6 to the side, I'm going to get 6 equals 3x plus 2y plus 6z. And that is the equation of the plane through those 3 points. Okay, I hope that was helpful, and I'll see you in the next video. All right, this is example 3. And in this example, we want to find the vector parallel to the intersection of the lines of the planes 3x minus 6y minus 2z equals 12, and 2x plus y minus 2z equals 5. So we want the vector parallel to the line of intersection. So if these two planes, if you can imagine, met, let me extend that out maybe like this. So they were meeting along this line right here. Okay, the two planes would then intersect along that line. So this maybe is behind that plane, if you can see the intersection there. And so that's what we're looking for, is the intersection. So that this plane kind of goes behind it like that and then extends out like this. And so we're looking for where does these planes maybe intersect, or maybe the intersection is down here somewhere. So we're looking for that line where those two planes intersect. And then we want the vector parallel to that line of intersection. All right. So the first thing to do is find the vector normal to plane 1. It's going to be too hard to write all that. So I'm just going to write it and say it in words. So N1 will be the vector perpendicular or normal to the first plane there. So this is going to be plane 1. This will be plane 2. And then we'll use that information to then find the normal to those two normals. Ooh, that's a lot of normal. I guess everything is normal. All right, so we have 3, and then we have what looks like -6, and then a -2. All right, so there's the first normal. That was hard to find. The normal 2 is going to be, can you guess it? 2, 1, -2. Is that what you got? If you did, great job. All right, so those are our two normals. So that was pretty easy. And then now we want to find the cross product of these two. So N1 cross N2. This is going to give us now the normal to these two normals. So these two normals make a plane, right? They're two vectors. That's two vectors required to span a plane. So if you cross them, you get a vector that's normal to these two vectors, and that's what we're going to do. So crossing them, we get 14, 2, and 15. Okay. All right, so that is the normal vector to those two normals. And Expanding on our last example here, just to kind of give you a geometric interpretation of it. So here are my equations of the two planes, 3x minus 6y minus 2z equals 12. That's that one. You can kind of see it there. And then I have 2x plus y minus 2z equals 5. That's that equation that gives this plane here. So putting them both on, you can see then where they intersect, so along that line, which we can connect directly here. So you can just see the intersection of the two planes there. And so if you're wondering why is the normal of the of the normals a parallel line, uh, think about the plane that is spanned by the normal coming out of this sheet and the normal coming out of this sheet. Okay, those two produce this line, and so the normal that results from those cross products is the line in black, and you can see that that would create the direction of the line that is, in fact, the intersection of the two planes. Okay, so the black line is the normal, and if it's coordinate free, so I can move it down and up if I like, but you can see that it's definitely parallel to the line of intersection of those two planes. So that is why when you take the normal of the two normals corresponding to the two planes, you get a resulting vector. The normal of those two normals is in fact perpendicular. All right, I hope that was helpful, and I will see you in the next video. Here in example 4, we're looking for the point where the line x equals 8/3 plus 2t, y equals negative 2t, and z equals 1 plus t intersects the plane 3x plus 2y plus 6z equals 6. All right, so we know that the points must satisfy the plane coordinates, so we can plug those directly in. So 3, we have 8 thirds plus 2t plus 2 times negative 2t plus 6 times plugging in z, what is the 1 plus t? That's got to equal 6. So we get 8 plus 6t minus 4t plus 6 minus 6t, that's a t, equals 6. So those 6's cancel. We have those t's cancel, and so you get 8 is equal to 2t. So 4 is equal to t. Uh, Something didn't quite catch right. This is a positive right here. This is a positive 6t. I had a minus. This was a plus here. I don't know why I wrote a minus sign there. So that, those 6t's don't actually cancel. So let me rewind. And I have 6t minus 4t, which is a 2t plus. So that's going to give me 8t plus 8 equals 0. There we go. I think that takes care of all of the minus signs. Be careful with your signs. So you get negative 1 is equal to, nope, negative 1 is equal to t. That makes sense. Okay, so negative t is equal to, or sorry, t is equal to negative 1. So now that we know what t is, we can plug those back in to find x. So x of negative 8/3 minus 2 is 2/3. Y is 2. And z is 0. All right, I hope that was helpful, and I'll see you in the next video. All right, in example 5 here, we want to find the angle between the two planes 3x minus 6y minus 2z equals 15 and 2x plus y minus 2z equals 5. As the hint indicates, the angle between the two planes is equivalent to finding the dot product between them and solving for the missing angle theta. So let's continue. Let's find the normal to the first vector, the normal 1 corresponding to the first plane, and the first normal is 3, negative 6, negative 2. The second normal is, that's for this plane here, is 2, 1, and negative 2. Okay, so those are the two normals. So let's consider the magnitudes and the dot product. So N1 dotted with N2. That gives a value of, let's see, 3 times 2 is 6, minus 6, negative 6, minus positive 4. So it looks like it's going to be getting a value of 4. And then the magnitude of N1 is 9. That's the square root of 9 plus 36 plus 4, which is what, 49. Square root of 49 is 7. And then the magnitude of N2, which is, let's see, 4 plus 4 plus 1, 4 plus 4 plus 1. What is that? 8, 9. So that's 3. All right. So then the cosine of theta, the angle between, is N1 dotted with N2, with N2 over the magnitude of N1 times the magnitude of N2. So if I take the inverse cosine of this mess, I'm going to get theta is equal to cosine inverse of 4 over 21, which is about 79 degrees or so. Okay. All right. I hope that was helpful, and I will see you in the next video. All right. In our last example here, we're looking at finding the distance from the plane to the from the point to the plane. If I can speak English a little bit better. So we're looking to find the distance from the point S to the plane given here, 3x plus 2y plus 6z equals 6. Okay. So from the notes, you can see that we know that the distance is given by the vector ps divided by the magnitude of the unit vector pointed in the unit normal vector, I should say, that dot product, and then the absolute value of that dot product. So let's compute the vector ps. That's the vector from the plane to the point S. And so if we do that, we would get that value is, looks like it'll be 1, -2, and 3. Almost as easy as 1, 2, 3. And so the normal then is going to be also 3, 2, and 6. That's the normal to the plane. That should come directly from here. So that should be pretty obvious. And then the magnitude of the normal, 3 squared plus 4. So 9 plus 4 plus 36. 9 plus 4 plus 36. That we just saw that is 49, which is 7. Okay. All right. So the distance then is the dot product of PS and N. So PS dot N is going to give us what? 3 minus 4 plus 18 divided by 7, which is, looks like 17 over 7 in absolute values. Okay. And we have our distance that we were looking for. Okay, I hope that was helpful, and I'll see you in the next video.